Speech Pitch by Iska Sak.
Hi there, and welcome to Speech Pitch by Iska Sak. I'm Pascal, and today I have with me Aruna, Jashu, and Rani. And all of you just competed in the Science Slam at the Speech Science Festival here in Rotterdam. And yeah, I would be very happy to hear like a bit of the pitch that you were respectively bring up on the slam. And let's start with Aruna. Could you first tell a bit about yourself, please? What are you doing here? And
Yes, I'd love to. My name is Aruna. I'm from the University of Washington in Seattle from the States. I am a co-founder of Koal Labs, a research-focused startup that aims to help people master their pronunciation and accent using movies and TV shows where a user can watch their favorite movie or TV show clip and the actor serves as a point of reference for the accent feedback a user receives. My research is primarily focused on phonetics and linguistics-based research.
Nice. Yeah, thanks a lot. Thanks a lot for the intro, and very cool to have you here, of course. And could you briefly then give the pitch that you were doing at the Science Slam just now?
Yeah, absolutely. So the platform is centered around being able to transcribe the user's accent and then also the actor in the movie's accent. And to actually compare accents is quite difficult, but luckily there is an alphabet called IPA, which can basically describe how a person pronounces something rather than using like English text, which oftentimes has a lot of ambiguities in how to pronounce something. You can do phonetics to be able to actually describe an accent. So the goal is that we use machine learning to transcribe the phonetics of the user and then also transcribe the phonetics of the movie actor. And this way you can actually compare the phonetic outputs and be able to see where in distinction the user's speech actually compares to the movie actor reference. And then from there, in natural language, without the user ever having to know anything about IPA or phonetics, you can describe to them intuitively how to pronounce and mimic the actor's sound and speech. And so the more challenging part about this task is that phonetic transcription oftentimes is centered around modeling native speech. So oftentimes standard American English speech is the primary point of the training data that these machine learning models are trained upon. But if we really want to truly help users master their accent, it's important to be able to accurately model their phonetics and do the phonetic transcription on non-native speech. So in our training data, we need to have a lot of non-native speakers in the data set. So one of the biggest fallbacks that we had when we were training on this is the fact that oftentimes annotators hear things differently. And so it's really difficult to have accurate data that actually reflects the true phonetics that a person is saying. So I'll give you a concrete example. For instance, let's take a Mandarin speaker from SpeechOcean, which is a data set. A Mandarin speaker would say something like they or them instead of they and them. And you'd want to model this in the phonetic output. So you'd say the Z phoneme, the E phoneme, and so forth. But if a phonetician has a Mandarin speaking background, they actually might end up kind of misinterpreting the phonetic and sometimes have their own bias cause them to actually annotate slightly differently. They'd actually annotate the Z sound as the TH sound instead. And so all of these kind of issues we need to account for to be able to create a model that is truly inclusive and diverse. And at the same time, also make it fast on inference so that it can serve millions of users who want to master their accent.
And just a quick follow-up question. What feedback would the user then get? You are modeling their speech, and do they get an example of how it should be correctly pronounced, the respective phrase, or how does it work?
Mm-hmm. Yeah, very good question. So lots of work in phonetics and also language learning has been done already, whether it's from people teaching movie actors how to master an accent or people trying to help language learners master an American accent. Usually the best way to communicate how to produce a sound is by, one, talking about it in terms of their native language. So you say, okay, well, as perhaps if you're a Japanese speaker and you fail to say the L sound because most Japanese speakers can't say that, you can say, well, you're going to start off by saying the E sound and you're going to raise your tongue. And you want to talk about it in terms of mouth placement. And as users get used to the platform, ideally they get more sensitive to the placement of their tongue in their mouth. And you begin to describe, okay, you want to push the back of your tongue up, and you begin to produce that sound. There's been research done about like visually showing what's happening in your mouth too. But we found that actually it's not always effective in helping people. Most people are freaked out when they see the side of their mouth and they're like, what is this weird like tongue movement? And they don't make sense of it. So describing it in natural language and keeping explanations brief and only giving them like 2 or 3 key points of things to actually work on versus like a million things to do is the most important.
Thanks a lot, Aruna. And next up is Jashu. And please introduce yourself briefly if you like. And just say a bit about yourself and how you ended up here today.
Yeah, so my name is Jashu and I come from Groningen University. Originally, I come from China, and last year I came to the Netherlands for master study. I was doing master study of voice technology, so I learned a lot about speech. But I always love music a lot, so at the end I decided to do something about singing voice synthesis for my thesis, and I was presenting today at the Science Slam for this topic.
Awesome, yeah. Thanks a lot and cool to have you here. So could you please give a brief description of your talk at the Science Slam, like the pitch that you did there?
Yeah, so my topic was about singing voice synthesis with limited amount of data. So singing voice synthesis basically means you gave the AI model lyrics and also the music notes and tempo, etc. And you choose your AI singer, and then the model would already generate the human singing voice automatically. And this application actually is quite mature. It helps music producers to make demos, for instance, efficiently. But the problem for that is that it only supports 4 languages at the moment. It's only English, Chinese, Japanese, and also Spanish. So I was thinking like, why it's so difficult to extend those to more languages. So I deep dive into that, and I found out the problem is about the data, because to train such kind of the model would mean you need really massive, high quality and also well annotated data, which is almost impossible to get it. Yeah. So that's why I want to develop a methodology that could help to train such kind of the model with very limited amount of data. So that's what I did. So I talk a little bit about the detailed method in the Science Slam activity. Yeah.
Oh, cool. Yeah. And please do go a bit into detail here, of course. So what project did you do then for the thesis, and how did it work out in the end?
Yeah, so I basically did something. I used a diffusion model to generate the thing, and I want to do the transfer learning from an English model to a German model. And what I did is I try to do the phoneme mapping between English and German, because both languages sounds very similar phonetically, and it's easier to find similar phonemes for these both languages. And I also studied German as my bachelor study, so it's for me easier to interpret the model training. So I can also sing, of course. So that's why that's why I did that project. And also one of the data set I was made by myself with my own voice. Yeah. So I did many experiments, and at the end we have the result that with 15 minutes of good quality data, you can already train a model would be able to sing in another language. 15
minutes only?
Yeah.
1-5. Cool. Okay, wow. That's some good result, yeah?
Yeah.
So thanks a lot. Yeah, that's also some very interesting topics. So thanks a lot, Jashu. And next we have Anur. Thanks a lot again for your line.
Thank you.
And Rani, it would be really cool if you could give a very short, condensed overview over the talk that you presented at the Science Slam.
Yes, of course. What I was trying to do is I trying to use adversarial attack to protect the human voice by being voice cloned by current zero-shot TTS models. The idea is we add some very minimal perturbations on the human audios, and we use the gradient guidance to disrupt the semantic token. We get it to somewhere else, to another reference token, so that we create a misalignment from the semantic token on the original speech and the provided transcription. This will disrupt the downstream LLM outputs.
And did you bring some examples for that along for the slide as well?
Yes, indeed. First, I showed how current zero-shot TTS systems are, how powerful they are. I showed that by giving around 10 seconds voice prompt, the TTS model are able to capture the timbre from the speaker and output a very similar speech as the original speaker are spoken. And then I show that with adding my perturbation, so after adding my methodology to protect it, we successfully correct the output of the TTS system so that it can only generate a meaningless voice.
Ah, cool, yeah. And is this readily usable, like open source available? How can people start using this technology?
Yes, the code are online and the audio demo are also online, but the methodology currently are white box, so it only works on existing open source TTS systems and it needs adaptations. We currently only have adaptations to Spark TTS, Cozy Voice, and VLE, so we have the protection for these three particular system, but I believe as long as it's open source, it will be very easy to adapt this technology to other models.
Cool. And could you briefly tell your affiliation, like which department you're working with? Are you doing PhD or university?
Yes, I study at TU Delft and I'm a master student computer science. And this project is an honors master project with the distributed system lab at TU Delft under the supervisor of Professor Lydia Chen.
Cool. Yeah. Thanks so much. Thanks so much for your overview.
Thank you.
Thanks for tuning in to this bonus episode. We might be interviewing your favorite speech researcher in the future, so be sure to subscribe to wherever you're listening to your podcasts. You can also follow ISCASEC on X and LinkedIn to stay updated. Until next time, have fun.
Speech pitch by ISCASEC.